So hello guys, in this video we will see approach to create LaTeX table only using Python and Panda, and why should you care about this. So let me show you first some facts about LaTeX tables. So if you're already worked with LaTeX, you know that sometimes working with LaTeX table can be quite troublesome and sometimes painful. So if we want to create a LaTeX table, basically you have to do it by hand, and tweaking the table can be sometimes difficult if you have a large number of columns and large number of rows, and the actual formatting inside the table can be tedious. Also, it is prone to errors. For example, if you want to change some values, specific value in your column, especially if the table is large, there is a higher chance that for some reason you forgot to place some, for example, delimiters, and the whole table collapse, and this is very painful. And by this, with this new way to create LaTeX table, when we want to avoid this and automate this process, so we do not have to directly manually fixing the table by hand. Also, if, for example, you did create your LaTeX table, and for some reason you need to have maybe this LaTeX table in three different ways with three different type of experiment, you need to recreate this table by hand. So in terms of reproducibility, it is quite low, and it's also time consuming. The next one is quite interesting, because sometimes in our LaTeX table we need to highlight some specific value based on some kind of criteria that we have set, or some kind of value that we want to showcase in our table. And this can be quite troublesome if our table is quite long with many rows and many columns, and when you're working with numbers, when table is large, it can become messy, and you also have, for example, for me, I have sometimes difficulty to see clearly when the number are packed. So this feature helped me a lot when I want to highlight a specific value inside my table based on some kind of threshold or value that I've set, either that I calculated automatically with Python, or a value that I already know that should be more or less in the column. And the last one is also linked to this, is, for example, I have my CSV with all the raw data that I have, and what I want to do is basically fixing the floating position in it without having to touch the raw data inside my CSV. So for example, I have a CSV that describe experiment that I did. In those experiment, the floating value inside my CSV contain many digits, and in my LaTeX table I just want 2 digits, and with just one argument I can do this pretty easily. So yeah, that's basically the motivation of having this. We want to be able to automate the process of creating a LaTeX table inside of scientific workflows. And the rest of the video, I will show you first the stack, what we need to create the LaTeX table. Then I will show you some example, the different examples that I've been creating for the purpose of this video, what can be possible. And last, I will be presenting you the code that I've been using to create those LaTeX tables. So the stack involve Python, as I told you, Panda, and the CSV that will be representing your experiment and your LaTeX tables. So basically, you just have to have the column that you want in your LaTeX tables in your CSV, and then the row are the different values that you either have created by hand or by a script, or when you are doing, for example, different experiment and you want to monitor them, this creates your CSV, and this CSV can be used to create the LaTeX table. So basically, then we need a script, and the script, there is two key elements in the script. Is loading the CSV with Panda that will create this data frame, and the next thing is the actual, the real key here is the magic is with the method toLaTeX. So the data frame who said do have method that is called toLaTeX, and this is where the magic is, and you will have some argument that will be presenting you later on that you can use and modify the aspect of your LaTeX table. And obviously this toLaTeX output a string that we can then use, and for example we can add in this string some element at the beginning. For example, if we want to add specific packages, if we want to add a specific type of documents, and if we can also add some stuff at the end of the string to make sure that the full document is properly defined and can be run directly into a LaTeX compiler. Then this function, basically this string can be saved as a text file, which is quite basic in Python, and then we can take our most loved compiler, Overleaf or Text Studio, to compile the text file, and then we have our table. So now I will be showing you the different example that I've made with this pipeline on Overleaf. So now let's go to Overleaf. So yeah, I think now we are here, and as you can see, those are some examples that been done with the code. So those are, first example is this one. So yeah, it is quite basic. So we have our caption, some columns named, and some values. The table looks great. We are also, also possible to, as I told you, highlight specific values inside the table. So in this column and this one, basically highlighted based on some kind of criteria that I will show you later on. The next table is was to illustrate the fact that we can work with big tables, and we can set the precision for all the table at once. And in this case, it was like two-digit precision. In the other example, it's the same, but just to show that you can have floating point and string and int, and you can still apply the precision. In this one, it was just 1 digit. And this one was for, which is quite interesting, for the multi-header LaTeX table. So for example, if I do have two headers, so employee info and work details, I can create sub-columns, sub-headers. So employee info will have the ID and the name, and the work detail would have the joining date. So it can be quite handy, for example, if you're working with, let's say you have like an experiment and you are monitoring different kind of metrics. So one experiment, and in the sub-column you have different type of metrics. So this example will be used for this type of LaTeX table. So now let's go to the code to see how we did this. So this is the actual code that I've been using. It is basically a Jupyter notebook, and this code will be, I will drop the link in the description of the video. It will be on my GitHub. And if you have any question, drop down a comment into the YouTube comment section, or you can leave an issue in the GitHub repo. So now let me explain to you like how this code is working. And as I told you, we only need Panda to work this. I've used the re package, but this is not mandatory, and as you will see later on, it's like just for a specific use case. But the real magic comes from Panda, and as I told you, this toLaTeX function. So basically, what this function take as an argument is the data frame itself, the name of the file that we want to save, the format of the precision for the floating. So it follows the Python formatting for floating precision, the string associated to the caption, the label also, the string associated to the label. Those two one were quite, they are not directly coded by the data frame, by Panda. So we needed to add this if we want it centered. So I did this little bit of code that's why I used the re package. So to make sure that I replace the beginning table with the centering in the right order, and I just want to search the position. And the position is also, as you know, when you have the begin table, you can have in square bracket some string that will be giving you the actual position, and or you want to encode the position of your table inside your LaTeX document. There's also two other arguments that are not in the signature of this function that are directly in this, is the column format. So the column format is basically how you want to align your LaTeX tables. So this string will process a letter for each column. So if I want to, let's say I have 4 columns, I want to center all the 4 columns. So the string will be CCCC 4 times. And in my example that I'm showing now is basically L for left centered, and then C multiplied by the number of columns -1, because we already set for the first column. And yeah, so left for L, left centered, and C for right, for the normal centered. This argument is for escaping if there is problems with spatial characters. So yeah, this one is for doing this. And you can also add positioning directly with this argument, and it will be using the structure of the classical positioning in LaTeX. And if that's why I'm telling you that it is not directly coded, if we want to center it and have the position, we need to encode this by ourselves. So that's why this code was added. Then, as I told you earlier, is this LaTeX table is a string, and this string can be placed into another string. And what we have done here is basically preparing like a text file with a structure of a document and some packages that are quite useful when working with LaTeX table. Then, as usual, we saved the file using this command, which is quite basic. This function here is used for the styled version of the table, and why the styled version is not directly implemented here is because we cannot use, when we are using styled, the way I have implemented things is using the styled version of the DataFrame, which is a method directly implemented in DataFrame. And when you're using styled, you cannot give any argument to LaTeX. So we need to have everything done by hand. So that's why I've been coded the whole table myself. And this is fixed, but you can obviously add the position like we did here. So we can add the position here like we did with the format. So yeah, it's not that much of a big deal, but yeah, just to show in the example, we then have the caption, the label, and the end of the label. And this is the actual table with the styled columns, and the styled column is basically some value having some highlight, some text in it. So now I'm just loading some data frames that I've been showing you. So let's delete this, the actual results. So as you can see, that those are the results. I will be showing you also the CSV so you can see by yourself what they look like. So yeah, that's the actual result. And as you can see, those are quite simple CSV. And yeah, as you can see. Another thing that I didn't mention is in your LaTeX table, you should also, no, in your CSV, sorry, you should make sure that all the columns that you are defining do respect LaTeX formatting. So it do not create any problems when you are saving the LaTeX table. So for example, if you just let this percentage like this, it will be rendered weirdly. So just want to make sure that this is using the LaTeX notation to render the percentage the right way. Same for this. If I'm using this var like this, var dash is 6 without the dollars sign, this will be rendered weirdly. So I want to add those $2 for making those as variables. In this also I made a mistake. As you will see in the example, if I render this, this should be like this way, because this will be rendered as var 1 and the 0 will be off of it. So this one will be now rendered correctly with var and in the sub index as 10. So yeah, make sure that your columns are, if you have variables or equation in your columns, make sure to just like change before making or using the code. It will save you a lot of headaches. Same for this. So it was large tables, and the sale data, as you can see, yeah, it's also pretty much the same. So now let's delete all of this to make sure that we are able to create those LaTeX tables. And I'm not like just showing you the LaTeX table. Maybe I did it by hand. It would be quite funny. And let's run everything from up to bottom, and should normally work. So yeah, should be creating the table now. As you can see, those tables are created. And now let's dig into the code. So first example, quite basic. We give the data frame, name of the data frame table that we want, the formatting. In this case, we want 2 digits, the caption and the table labels. We want this centered, as you will see that this is actually centered, and this is the result. It is quite handy, as you can see here. Yeah. So I think this is pretty look pretty nice, and it can be directly used inside your manuscript or any kind of scientific papers that you are writing. Also, now let's go to a different type of problems. Now let's say that we want, as I told you, highlight some kind of specific value inside our data frame. So the actual pipeline to do this is basically defining a filter, so a condition that we want to apply to a set of columns. So in this example, it will be 2 columns, and this only condition will be this. So it will directly go through all my columns that I've been giving, and for each value inside the column, it will test if the condition is met. If the condition is met, it will change, either it will stay the same. In this case, it's just verifying if the value is greater than 90, but obviously you can set any kind of condition that you want. It can be 2 lines, 3 lines on, or even a function. Then we are using then this def.style.format, and then we call this dictionary inside. And for each columns, we apply this function. And then what we want to do later on, we want to extend this pipeline is basically if we want to apply, for example, different type of filters depending on the columns, what we need is basically creating those different convention, those filters, and making sure that for each columns we apply different function, and we use zip to loop for different function and different column at the same time. And the formatting is the same. So the first function will be applied to temperature, and the second function will be applied to success rate. As you already mentioned, I have this set because I have the name of my columns is with the LaTeX notations. Then, as you can see, the result will be this. And for the first example, we went to the temperature column and the success rate, and we wanted to check, we wanted to highlight any value that were greater than 90 in the temperature, the actual value all the value do not meet the criteria of this, so it is not. And for the actual success rate, the value is then set with all the value in the column that are greater than 90. So yeah, as you can see, it is done like this. For the next example, we set two functions, and in those function, the criteria is basically the max of the column, and that's one you want to aim. You want to do this with a modular way. You do not want to set your threshold beforehand, because maybe you do not know already what it is, or if your LaTeX table is large, you don't want to find it and then apply the threshold. You want the code to fully do it by itself and directly automate the full process. So in this example, just doing the max of the column, but it can be another type of filter or another type of function that I want that will create this val test. And then it will set the condition. This condition can be also different, but just for the purpose of the video, it's quite the same. And as you can see, these are the same basic function, but can be different. You can have any kind of condition that you want to apply. And then it is applied. As you can see, all the value that are less than the max are highlighted, and all the value that are less than the max, which is 95.2, are highlighted. For the multi-column LaTeX table, which is what we need to do is basically create a data frame, the structure of a data frame with columns and value inside the different column. And if we want to have a multi-header LaTeX table, what we need to do is we need to call the multi-index and have the set of tuple that will make sure that the subcategories will be implemented. So employee info will be the first columns, and we have two sub-headers, which would be ID and name, and also work details will have two sub-headers, so two sub-columns, which will be department and joining dates. And this is the example that I've showed earlier in the LaTeX. And the last things that I wanted to show you is basically being able to control the precision for floating point inside your table, which is quite interesting. So what you do is basically using the formatting of Python, you can directly fix the actual precision of your table just by using the Python structure for formatting. So let's change it. Let's say I want 4, and it's here I want, let's say 3, and this will be on. And now we can, so as you remember, the precision table, so df experiment data, I think it was this one. So maybe I can do this with a larger example so you can see. So def large table 1, so it should be this one. So yeah, in this example there is like 4 type of precision. There's 4, so let's now do this with 3. Yeah, so it's done with 3, so that's quite nice. And now what we can do is we can directly go to this and see that there is like 3 sets, 3 digit as a precision, which is quite nice. That it is directly implemented in it. And actually would have to change the raw data inside the CSV. So yeah, I hope you this was quite useful. As I told you, I will link this. I will give the link in the YouTube description. And if you have any question, please leave down a comment in the YouTube section. And see you in the next video, guys.